Okay, so the last two types of graphs we're going to do are secant and cosecant graphs. And the first thing I'm going to tell you is that you can graph sine and cosine, you can graph secant and cosecant. That's another reason why we spent so much time last week with sine and cosine. Okay? So, what do these functions have in common? They are inverse. Inverses of others. So secant's the inverse of cosine, cosecant's the inverse of sine. So if we look at cosecant x, first off, you ask yourself, is it periodic? The answer is yes. Even though it's not continuous, it's repeating itself over and over again. So it's periodic. Now, are there asymptotes? In other words, is there a line we can draw in that separates all the curves? The answer to that is going to be yes, and we're going to show them to you in a second. Let's identify some features. So first off, all right, there's sine added in. 2 sine 1/2 x, 2 cosecant 1/2 x. So there's the two graphs in. The curves represent the cosecant part that we showed you above. And then that's the sine that you recognize from last week. If you draw these in, okay, that's the vertex of each cosecant curve. Well, you'll notice that that shows up either the maximum or minimum of the sine graph. So the vertex of each curve on the cosecant graph is at the maximum or minimum of the sine graph. These curves are bounded by asymptotes. Okay, now where are those asymptotes? If you draw them in, notice, look at that, look at that, look at that. If I draw another one, it's going to be here. If I draw another one, it's going to be there. What do they all have in common? Well, that's where the original graph, in this case the sine graph, so if I draw the remaining ones in, there we go. Okay. So those asymptotes are all created where the original sine is 0. That's because if sine is 0, cosecant does not exist from what we studied previously. Okay. Alright. So this is what I would do at the bare minimum when graphing secant and cosecant graphs. Okay? With a dashed curve to distinguish the two. And you'll see what I mean when we do the practice problems. Draw the inverse functions graph. Okay? For secant, the inverse is cosine. For cosecant, the inverse is sine. At each maximum or minimum, draw a curve in the opposite direction. So at a maximum, it opens up. At a minimum, it opens down. At each 0, draw your asymptote. Okay? So the domain, so when you have to do this and you have to answer questions, the domain is x is not equal to the first asymptote plus pi n b, where b is the coefficient of the variable. The range, y is greater than or equal to the maximum of the inverse or less than or equal to the minimum of the inverse. We'll explain that to you in a moment. Period is 2 pi over b, same as sine and cosine. So sine, cosine, secant, cosecant, the period is over 2 pi over b. Tangent, remember, is pi over b, as well as cotangent. Asymptotes, x equals the first asymptote plus minus, and we'll get rid of the 2 there. Because basically, as opposed to tangent and cotangent, which had 1 asymptote per period, secant and cosecant have 2 asymptotes. So for this one, okay, remember it's y equals 2 cosecant 1/2 x. Okay, so the 1/2 is my b. So my period is 4 pi. 2 pi divided by 1/2 gives me 4 pi. Alright? Now, my domain and my asymptotes are related, just like with tangent and cotangent. The domain starts with x not equal to, the asymptotes start with x equal. Now you start with your first asymptote, or any asymptote you want. So basically, since the period is 4 pi, halfway through the period, sine's at 0, so basically we can use 2 pi. Alright, and that, my friends, is right here. So that's 2 pi. So that's where my first asymptote is located. Plus minus. Since my period was 4 pi, I cut that in half. 2 pi plus n. 2 pi, right over here. 2 pi plus, well, I already have the 2 pi. So 2 pi plus minus half of that, which is the period, which is 2 pi n, where n is any integer. And then the asymptote x is equal to 2 pi plus minus 2 pi n. Alright, so we'll go through several practice problems and you'll get an idea. Alright, and this week we'll work on all of those, so you're good to go.